Welcome students, welcome to today's class, Bohr's Atomic Model. Bohr's Atomic Model stated by Bohr in the year 1913. There are four important postulates in Bohr's Atomic Model. And Bohr's Atomic Model specially speaks about electron, only electron. The first point is like this. Electron is moving with high velocity. So remember last class I told you the velocity of electron, it's very high. And time taken by the electron is also very less, isn't it? It's 1.5 into 10 to the power of minus 16 seconds. That is the time taken by electron to complete one revolution. 1.52 into 10 to the power of minus 16 seconds means is a very minute time. Within that time it completes one revolution. That means it is moving very fast. So that point is very clear that electrons are moving high velocity. The next one is what? In a definite path. So these are the paths. Nothing but what? Shells. As I told you, these are also numbered as n is equal to 1, 2, 3 and so on, which are also stated as k, l, m and so on. So electrons are moving high velocity. 1.52 into 10 to the power of minus 16 second is the time taken by electron to move around nucleus. Great, it is very minute time. After 0.15 zeros, then comes 152. Why it is taking that much short time to complete one revolution? Because the size of the atom is less. In that nucleus is there, which is much more lesser. And the next one is what? It is moving in a definite path. It is said that it is moving definite path, and these paths are these path, okay, are also given values like n is equal to 1, 2, 3 and k, l, m, n. So electrons are moving with high velocity in a definite path called orbits or shells. And as long as the electron remains in the same orbit, suppose that these two electrons and these two are there, suppose, imagine, and they want to remain for lifetime, they want to remain in the same orbit, then their energy will be constant. And finally, these orbits or shells are called stationary orbits or stationary shells. That is the first point. Okay, what is that? Electrons are moving high velocity. I clearly stated that one. Electrons are moving high velocity in a definite path. This is path called orbits or shell. These are called orbits or shell. As long as the electron remain in the same orbit, okay, its energy remains constant. And these orbits or shells are called stationary orbits or stationary shells. The second point is, where did you stop the first point? Stationary orbits or stationary shell. Second point starts there. Each stationary orbit is designated with n value 1, 2, 3 or k, l, m and so on. The orbit which is nearer to the nucleus. Which orbit is nearer to the nucleus? K. In every shell it will be k1. In every atom, it will be k. So orbit which is nearer to the nucleus is having less energy compared to orbit away from nucleus. Quite natural. Suppose as the shell increases, what happens? Size also increases. Because the length, whatever you speak about, the length of the orbit is also increasing. So electron which revolves in this one requires more energy compared to this one. That's why it is very clearly said that orbit which is nearer to the nucleus has less energy compared to orbit away from nucleus. Super. Now coming to what? So according to the second point, I am speaking about third point. What is it told? It is told that electron which is away from the nucleus is having more energy. So if a more energy electron jump into lower one, then what happens? Since it is having excess energy, it will give out the remaining energy in the form of radiation. In the form of radiation, it will give out. Suppose the electron jump from lower. Now when you compare this one, it is k, l, m, n. This is lower, isn't it? So if an electron happens to jump from lower to higher, it is not possible for this electron to complete that revolution. Therefore, it absorbs energy to complete that one. Very simple. If an electron jump from higher to lower, extra energy it will give out in the form of radiation. If an electron jump from lower to higher, then it cannot complete that revolution. So it absorbs the external energy from somewhere and it completes its revolution. So this is what you mean. So it is also stated in the formula like E2 minus E1 is equal to h nu. H nu. H is called Planck's constant. H is Planck's constant with value 6.625 into 10 to the power of minus 27 second. or 6.625 into 10 to the power of minus 34 joule second. This is Planck's constant. Nu is frequency. So what actually it means? Why did you come across this point? Because it is very clear that energy is directly proportional to frequency. How can you know that energy is directly proportional to frequency? Yes, very good. So prism is when the light ray it bends and it comes out in the form of 7 colors. Supposed to go away like this 7. Which one has deviated less? Red. Which one has deviated more? Violet. So deviation is inversely proportional to wavelength. I have explained this in the previous class also. Deviation, which is having more deviation? Violet deviation is more, so wavelength is less. Red is selected as sign of danger because its wavelength is more. So red wavelength is more, so its deviation is less. Exactly, see this much only is the deviation. Now deviation is directly proportional to energy loss. So mornings and evenings appear red for us. The reason is very simple, that red loses less amount of energy, therefore it straight away strikes our eye. Why it loses less amount of energy? Because its wavelength is more. Wavelength is more, energy loss is less, inversely proportional. And the other one is what wavelength is inversely proportional to frequency. That is very clearly in the previous class also I explained you. This is the wavelength, the distance between two successive crests. This crest and this is crest. Therefore the distance between two successive crests is called wavelength. Now when you speak about violet, this will be the wavelength, like this it is. So it has less wavelength, but number of peaks are more. Here you have 2 peaks, within that time it is having more peaks. That means here frequency is more, and here frequency is less. Frequency is less means wavelength is more. Exactly, see wavelength is more, so frequency, the number of peaks very less frequency. Here wavelength is less but number of peaks are more, so frequency is inversely proportional to wavelength. Now coming to this, what do you understand from this? So you just rub down deviation, you remove wavelength, then understood. Energy is directly proportional to frequency. This is Max Planck equation. So based upon this, Bohr's model is stated. Okay, Bohr's model has come based upon this only, Max Planck equation. E is proportional to nu. So you come across that point here. E is proportional to nu. E1 is higher energy state. E2 is higher energy state. E1 is lower energy state. So when an electron jump from higher to lower, it is emitting in the energy in the form of radiation. Suppose it is opposite, E1 minus E2. Then it will be minus h nu. That means what happened? If an electron jump from lower to higher, right, it requires energy. So this indicates, minus indicates that it is absorbing energy to complete this revolution. Okay, and the fourth important part is angular momentum of an electron is integral multiple of h by 2 pi. Angular momentum of electron is integral multiple of h by 2 pi. Angular momentum means what? MVR, fourth point, Bohr's model, MVR, angular momentum. MVR is equal to NH by 2 pi. 2 pi indicates what? Pi means how much it is? 180 degree. 2 pi means how much? 360 degrees. That means stationary orbit. What do you mean by N? N is 1, 2, 3, principal quantum number, nothing but KLM, shells. H is Planck's constant. So he says that angular momentum is multiplication of mass of electron, velocity of electron, radius of electron. If you multiply all this, that is equal to integral multiple of h by 2 pi, where n is called integer 1 to 3, h Planck's constant with value 6.625 into 10 to the power of minus 27 second, or 6.625 into 10 to the power of minus 34 joule second. 2 pi indicates that the electrons are moving in stationary orbit.